Hi there, in this video I'm going to take the 1 bit of memory and create a 1 byte of memory. Okay, so we've got the CPU mem1 sitting here. Okay, so I can place that up here and I can take 8 instances of this. So Control D copies it, and I'll Control D this. Okay, and finally Control D. Okay, so now we've got 8 instances. We're going to have an input. Okay, so but we'll only want a single input pin. Okay, so there's an input pin there, and it's a splitter. Okay, so it creates a bus, so we don't want 8 inputs, we want just one single input in the hierarchy. Okay, so we've got that bus there. So now what we'll do is we can connect this up. Actually, these got to be facing south. Okay, and again I'll face that one south. Okay, so these are the inputs and that's output. So that input there, so it goes to 0, 1, 2, 3, 4, 5, 6, 7. Okay, and the output here again you have to be careful because that's 0, so 0 is at the far end. Okay, so that's 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this is an input, so that's an input pin facing east, and it's an 8-bit pin. So there we go, and we just call that I for input. I for input. Okay, and this is going to be an output, so we'll put the output pin there, again facing east, and connect that there, and that's going to be O for output. Okay, and you'll notice there that the inputs are sitting at 0. Okay, the output there is sitting at an error value. Okay, it's at an error value. Okay, because it's in here. Okay, there's an error here. Okay, it doesn't know what value that's meant to take because there's a race, in effect, a race condition sitting there. Okay, so what we can do if we go to main is if we connect all the sets up together. Okay, that's the set. Okay, so in effect this set, it sets the bit or the byte in this instance into memory. Okay, so we put in a set pin at the bottom. So it's an input pin, but this is only a 1-bit input, and we'll face it north. Okay, and we can call it S for set. Okay, so that's our circuit built. So the way this should work is, put a simulation. When I change this to a 1, it will pass through whatever is in here onto the output. Okay, so it should pass all these zeros onto this output. So there you go, it goes 1 and all these zeros pass through, and it means that this input now is transparent and it passes straight through to the output. So if I change any of these, you see them changing. Okay, so there's a check on it, our circuit, that everything's working, those are all changing. So when I take the set value goes low, all of these are fixed. Okay, so in effect this wire here is fixed at that high level. Okay, and you can see that wire is going through here, so that's fixed. All that is fixed there, you can see it from there, it's fixed at a high level. Okay, so if I was to change any of these here, the inputs, although these inputs change, this output here doesn't change. Okay, so that in effect is the memory, that's the 8-bit memory, and it's passed through in a parallel fashion by these set bits here. Okay, so now what I can do is I can get in here and create a hierarchy. So if I go add circuit, I can call it CPU underscore let's say mem underscore 8. Okay, so that's the hierarchy we're going to create. Okay, so now I can go in here and go to main, and I can take everything here and I can go cut it all and paste it in here. Okay, so that's it now sitting in here, and now what I can do is I can go into edit circuit appearance and I'll change the circuit, okay, just the look of the hierarchy. So maybe make it there's a shape there, okay, width 2, and that's the output. Okay, that one is the set. Okay, I know you can't see that one there because it's off the bottom of your screen, but that's the set, and this here is the input, and we need this little section here as well. Okay, so I can delete that and I can give it in some names. We can call one is I for input, S for set, and O for output, and we can call it CPU mem 8. Okay, so we'll just grab these and we'll put them in the proper position. So I for input, O for output, S for set, and we can put that into CPU. Call it C, put it a bit further down there. CPU underscore mem 8. Okay, so now we've got a 1 byte of memory. Okay, so we can get in here and we can pick up our 1 byte of memory and we can place it in here. Okay, so that's all we have for this video. In the next video we'll add a little enable section onto this. So the sets the value into memory, but we need to be able to then enable that onto a bus. Okay, so we stick a little enable section on. So I'll look at that in the next video, and probably the decoder as well. Okay, thank you, goodbye.